Welcome back, minions. Let's keep on. Let's keep on trucking. We're going to do the hyperbolic trig functions, doing some examples of them. Let's take the derivative of a hyperbolic sine with x cubed on the inside. Simple chain rule. Sinh goes to cosh. And then we take the derivative of the inside. We got 3x squared. So 3x squared cosh x cubed. When we do cosh squared x, remember, in case you've forgotten, that is cosh x squared like that. So, chain rule. Bring the power down, and then take the derivative of the inside. And that ends up just being hyperbolic sine of 2x. Let's do, why don't you guys try this one? Pause the video, take the derivative of hyperbolic tangent. Remember, you've got the equations up here. They are the same other than the signs. Sine, cosine, tangent all have positive derivatives, and the other three have negative ones. All right. Tangent goes to secant squared, so tangent goes to sech squared, or hyperbolic secant squared. Then we got to, oh shit, look at this. Mistake. Let's fix this live. The inside doesn't change when you take the derivative. But we do need to take the derivative of the inside, and the derivative of the inside is 12x squared minus 14x. So we have 12x squared minus 14x times hyperbolic secant squared of 4x cubed minus 7x squared. All right, try that one. 1 over hyperbolic sine squared of x, just regular old x. All right, I'll assume you did. I rewrote it with a negative power, so we got a -2 up there, and then I took the derivative. So negative, you could have done the quotient rule too if you're a psychopath. -2 comes down, we have it to the -3, and then we take the derivative of the inside, which is cosh. So I've got -2 cosh over sinh cubed, which when we clean it up is -2 times hyperbolic cotangent times hyperbolic cosecant squared. Now, another variant is recognizing that sinh squared is cosecant squared, or hyperbolic cosecant squared. So rewriting it as that, taking the derivative of that, we do the chain rule, we bring the power down, and then take the derivative of hyperbolic cosecant. And the derivative of hyperbolic cosecant is negative cosecant cotangent. Multiply those in, and we get the same thing we had above. Or you could have done quotient rule if you're crazy. I'm not really writing out that one. Works. You got to teach you to work smarter, not harder. What about integrals? We can integrate x squared sinh x cubed dx. Now we don't have a formula for x squared times hyperbolic sine, so hopefully your first intuition is what? What have you learned how to do that might help us here? That's right, u sub. We're going to do u sub. We're going to do u equals x cubed. So du equals 3x squared dx. And we're going to divide. We have an x squared dx in the problem, so we're going to divide the 3 over, have a 1/3 du. And now we've got 1/3 hyperbolic sine of u du. We integrate that, we get 1/3 cos u. And it ain't about you. We didn't start with u. We're not going to end with u. We've got x cubed in there now. 1/3 hyperbolic cosine of x cubed. And don't forget, what is this called? You remember what that's called? The constant of integration. Good job. All right, try this one. Ooh, this is sneaky. Hyperbolic tangent. Now come up here. We don't have any integral for hyperbolic tangent. That's the closest we come to having an integral for it. So what do we do? Pause the video and think about it. See if you can figure it out. This is doable. You can do this. Don't Google the answer. What options do we have that we can do with tangent? If you said rewrite them as sinh and cosh, 1 over sine over cosine, that's a good way to go. Because then we can do a u sub on the bottom. U equals hyperbolic cosine of x. Du is hyperbolic sine of x dx. We have hyperbolic sine of x dx right there. That's our du. We're going to have du over u, or 1 over u du is natural log of the absolute value of u plus c, or natural log of hyperbolic cosine of x plus c. Remember, it ain't about you. Make sure you sub the value back in. Give that one a try. Hyperbolic cosine cubed of x times hyperbolic sine of x dx. Integrate that. Again, no limits of integration. Now, if you're not sure what to do the u sub on, you could try both. But remember when we did it in the trig one, it was putting it on the one that had the big power and the odd power seemed to be best. We're going to let u equal cosh x, so that du equals sinh x dx. And we got the integral of u cubed, which turns into 1/4 u to the 4th plus c. And it ain't about u, so we replace u to the 4th with cosh x to the 4th. Oop. Now, we do have a formula up above for hyperbolic secant, but it's of x. So here's another good time to use the u sub. Rather than trying to figure out what it'll be, just set u equal to the inside, u equals 5x, du equals 5 dx, and we've got 1/5 du equals dx. So we're going to take dx, replace it with 1/5 du. We're going to place the 5x in the hyperbolic secant squared of 5x with the u, and we have hyperbolic secant squared of u with a 1/5. Hyperbolic secant squared, the integral of that is tanh of u, and it wasn't u, so we placed the u with 5x. And that's it for these examples. Next, we're going to do hyperbolic inverse trig functions with the inverse of them. So let's make that a separate video. You're going to like that even less, but that's okay. Not everything's fun and games in math. It's supposed to work for it. Stay on me, my friends.